this video, we will study about the conditions of parallelogram. Now, we already have studied about the properties of parallelogram, in which we can say that the opposite angles of the parallelogram, they are equal to each other, whereas the sideways angles if add up to 180 degrees. Now let's study about the conditions for the parallelogram. We all know that if a quadrilateral is a parallelogram, then its opposite sides are congruent to each other. So here you can see that it is a four-sided figure which is said to be a quadrilateral, and it could be a parallelogram if this side yani QR is opposite to P which is opposite and the parallel to the PS, they are equal to each other. So if QR is 10 centimeter, then PS is also 10 centimeter. Similarly, QS and QR, they are equal to each other. QP are equal to or congruent to each other. So if QP is 5 centimeter, then RS is also 5 centimeter. So let's study about the two properties, the converse of the opposite sides of a parallelogram theorem. What does it say? That the both the pairs of the opposite side of the quadrilaterals are congruent, then this is said to be a parallelogram. So which means the same thing they are saying, in other words, that if AB and DC are congruent, also AD and BC are congruent, then this figure is said to be a parallelogram. Now you might say that always it will be a parallelogram. No, let's see here. Here there is a figure. Now here, yes, these two sides AB and CD are parallel to each other, but they are not congruent. So which means that this is not a parallelogram. So not all the four-sided figure is a parallelogram. Only a parallelogram is a figure whose opposite sides are congruent to each other. And whether if, for example, AB and DC are congruent, but AD and BC, they are not congruent, then we cannot say that that figure is a parallelogram. So second condition, it says that the opposite sides of the parallelogram are congruent to each other. So it is very important that this angle B and the angle D, which are opposite to each other, they are congruent. Similarly, angle A and angle C are congruent to each other. If this is the condition, then the figure is said to be the parallelogram. So there is a opposite sides of a parallelogram theorem and converse of the opposite angles of a parallelogram theorem. What else we say? We say that the converse of the diagonals of the parallelogram theorem. Now here the diagonals completely, yani BD and AC, they are not equal to each other. But if there is a center E which divides the diagonal into two equal parts, then you can see that on the same diagonal AE and EC are congruent, whereas BE of the other congruent and the other part of the diagonal is congruent to ED. And it doesn't mean that AC and BD are congruent. No, this is not a condition. Now what else? Opposite side criteria. If a quadrilateral has one pair of opposite sides that are congruent and parallel, then the quadrant is a parallelogram. So again, AB and DC, not only they have to be congruent, but they have to be parallel to each other. Okay, so now we can see that how can we prove that the given figure is a parallelogram. So in order to find out that if they are parallel to each other or not, the first thing is you have to find out the slope. The You have to find out the length of EG and the length of GH. Because with the help of the figure, you can say that they are congruent to each other. They are parallel to each other. But are they congruent? So for that, you have to find out the length of these two lines and make sure that the lengths are equal. And what is the formula to determine the length? Remember, if the vertices or the coordinates are given, then the formula is x2 minus x1 whole square, which you have studied before, plus y2 minus y1 whole square. Okay, so now step by step, let's go. So I want to show that FG is congruent to JH. I can see with my naked eyes that FG is parallel to JH. But whether it is congruent or not, let's check. Now what is FG? Look at this one, okay? The coordinates of the F are 1 and 3, right? The coordinates of the G are 3 and 2. Okay, so from here, we can say that this is x1, this is y1, and this is x2, and this is y2. Now find it out. Put it in the formula to find the value of Fg. Use the formula, here power 2. Use the formula, here power 2. From where I got the power 2? From here and here. And in the brackets, I write x2 minus x1. What is x2? 3. The formula minus, and 1 is the x1. What is my y2? This one, 2 minus, and then what is my y1? 3. I can write all in the calculator and get my answer. So it will be 3 minus 1, that is 2. 2 square is 4, and minus 1, 2 minus 3 is minus 1, minus 1 whole square is 1, and even if I write in the calculator, I will get square root of 5. Now, once I am done with this part, I will take the JH. So what is my J? My J coordinates are 0 and -1, and my H coordinates are 2 and -2. Okay, what is x1? Here it is x1 and y1, the coordinates of J, and the coordinates of H are x2 and y2. What am I going to do? Yes, I am going to find out the distance between the JH or the length of JH by using my distance formula. I make the two brackets with the power 2, and in between I will write the plus sign. I am going to use this formula. So this now in my case x2 is 2 minus, this is the formula minus, and x1 is 0. Then again my y2 is -2 minus formula, and then you can see minus 1. So minus minus minus, or I will write here minus 1. So minus minus also gives me the plus. So even you can write like that or directly do the calculation in your mind. Okay, again 2 minus 0 is 2. 2 square will be 4. Minus 2 plus 1 is minus 1, and minus 1 whole square gives me 1. Or I can write all this thing in the calculator and I get square root of 5. So what I have seen, yes, FG is congruent to JH. So I have proved that one side is congruent. But can I say on this basis that it is a parallelogram? No. I have to find out now the JF and GH by doing the same process. If you understood this thing, pause the video and see that if your answer matches for the second part with me or not. Let's do the same thing with the other part. So I have the coordinates of the J is are 0 and negative 1, and the coordinates of 1 are 1 and 3. And I have to prove right now that JF is congruent to GH. This is my task right now. So again I will name x1 and y1 and x2 and y2. Now let's find the JF by using the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square. So what is my x2? My x2 is 1. What is my x1? It is 0. Then my y2 is 3 minus, and my y1 is negative 1. So negative 1, so you can write like that, or negative, negative, positive. Okay, so now the answer is 1 minus 0 is 1, and 3 minus minus 1, 3 plus 1 is 4. So 4 square means 16 and 1 square means 1. 16 plus 1 is square root of 17. Or write it here. I write here square root of 17. Now I am going to find out the GH. So the coordinates of GH, G is 3 and 2 and H is 2 and negative 2. So let's try to find out. So this is my x1, y1 and H coordinates are x2 and y2. So I will just preparing myself. Now x2 is 2 minus x1 is 3. Then y2 is negative 2 and y1 is 2. Now 2 minus 3 is negative 1. Negative 1 whole square is 1. Minus 2 will give me 4. 4 square is 16. So again 16 plus 1 is the square root of 17. So what I have seen in the concluded that JF is congruent to GH. So I have proved two things, right? I have proved that FG is congruent to JH. Similarly, I have proved that FJ is congruent to GH. But I said that FG and JH looks parallel to me. But really, are they parallel to each other mathematically? So let's prove now this part. So in order to prove that FG is parallel to JH, and similarly JF parallel to GH, what I have to do? I have to find out the slopes of this line. Why? Because I know that the slope of parallel lines are equal to each other. Parallel lines must be equal. So at this stage, I have to find the slopes of these lines. So let's try to find out what are the FG. So I have the F, let's make it FG. Okay, so F is 1, 3 and G is 3, 2. Okay, so this is x1 and y1 and here x2 and y2. I am trying to find out the slope of FG. Now I know that the formula of the slope is y2 minus y1 over x2 minus x1. So what is my y2? It is 2. Y1 is 3. X2 is 3 minus x1 is 1. So 2 minus 3 is negative 1 and 3 minus 1 is 2. So the slope of FG is negative half. Let's try to find out the slope of, now let's try to find the slope of JH. So what are the coordinates of J? It's 0 and negative 1, and H is 2 and negative 2. So again I know, and I name it as x1 and y1, and here as x2 and y2. So let's try to find out the slope of m of JH. So now y2 is negative 2 minus y1 is negative 1. From where I got this minus? This minus is the formula minus. Okay, now y2, my y2 is 2, x2 is 2 minus x1 is 0. Now let's see, minus 2 plus 1 is negative 1 and 2 minus 0 is 0. So what I have seen, that slope of FG is congruent or is equal to the slope of JH, and hence proof that FG is parallel to JH. So now I have found that one line, these two lines are parallel to each other by finding the slope. Let's pause the video and determine if the other two lines are parallel to each other or not. So let's prove if the other two lines, that means that FJ are parallel to GH. So what are FJ? So we are trying to find out to find the slope of FJ. So the coordinates of F are 1 and 3, and the coordinates of J are 0 and negative 1. Name it as x1, y1 and x2, y2. So here, okay. So this is x1 and y1, and these are x2 and y2. So put it in the formula, y2 minus y1. So y2 is negative 1, y1 is 3. x2 minus x1, it means 0 minus 1. I write this in the calculator or in my mind. Minus 1 minus 3 is minus 4. Minus 4 divided by 0 minus 1, which gives me negative 1. Minus 4 divided by minus 1, my answer is 4. Now I find the slope of GH. So the coordinates of G are 3, 2, and the coordinates of H are 2 and negative 2. Again I will name it as x1, y1 and x2, y2. And now put it in the formula. y2 is negative 2 minus y1 is 2. x2 is 2 minus x1 is 3. So somewhere here, let's see here, 3, 2 and 2, negative 2, negative 2, minus 2, minus 2 and 2 minus 3. Yes. So minus 2 gives me minus 4, 2 minus 3 gives me negative 1, and negative 4 divided by negative 1 gives me 4. So can you see that both the lines have the same slope, which means that the line FJ is parallel to GH. Let's summarize. So in order to determine if the lines are parallel, you should prove that the slopes are similar by using the slope formula. Second thing, in order to determine that the two lines are congruent to each other, so lines are congruent, you have to find out their lengths are equal. And in order to find that the lengths are equal, you should use the distance formula. So here, whatever we have done, here is your answers. The brackets that support an adjustable basketball hoop can be modeled by KLMN here. Okay, this one. They are talking about this figure. For what values of x and y is KLMN a parallelogram? So we should know that in order to make sure that something is parallelogram, the two lines, the opposite lines should be equal to each other. So here we can say that KN must be congruent to LM. So what is Kn? It is x plus 4. And what is Lm? This is 3x minus 12. Now solve for x. Bring the 3x on the other side. So when you bring the 3x plus 3x on the other side, you will get negative 3x. Bring the plus 4 on the other side, you will get negative 4. Now x has no number. No number means 1. 1 minus 3x gives me negative 2x. Minus 12 minus 4 gives me negative 60. Divide both sides by negative 2 to find the value of x. I will get x equals to negative negative cancel, 16 divided by 2, or you can use the calculator to get the answer. So my x value is 8. Now I want to make sure am I right or wrong. So let's replace 8 here. So 8 plus 4 gives me 12. For Kn is 12. And 3 times 8 minus 12, it means 24 minus 12 also gives me 12, which means that Lm is also 12. Now let's try to solve the other part. So I know that Kl should be congruent to Nm if it is a parallelogram. So Kl is 7y and Ny is 5y plus 6. Bring the 5y on the other side, I will get negative 5y. So 7 minus 5 gives me 2y equals to 6. Divide both sides by the 2 and I will get y equals to 3. Now to make sure that I am right, I will replace my values here. 7 in place of y I will write 3. 7 times 3 is 21. Here 5y replaced by the 3 plus 6. 5 times 3, 15. 15 plus 6 also gives me 21. So we can see that the given figure is parallelogram. So we can just make the lines or the opposite lines equal to each other and find the unknown value. So again the same question, you have to prove if the given figure is a parallelogram. So for what is the first thing? First thing you have to show that RS is congruent to QT. Similarly, QR must be congruent to TS. And hence you have to show that RS is parallel to QT and QR is parallel to TS. So I am saying that this line should be equal and parallel to each other and this line should be equal and parallel to this line. To make sure to prove this, first of all, in order to prove that the lengths are congruent, here I will use my distance formula, and in order to prove that they are parallel, I will use my slope formula. So let's try. Let's try and see that what we are going. Okay, so let's talk about the RS. Let's talk about my R and S. So what are the coordinates of R? It's negative 1 and 3 and SR is 2 and 0. So let's use the distance formula or find the length of RS. So let's name it as x1, y1 and x2, y2. So my x2 minus x1, which means 2 minus minus 1. So it will gives me plus 1 whole square. y2 minus y1, y2 is 0, minus 3 whole square. Write in the calculator. So 9 plus, okay, so 2 plus 1 is 3, 3 is 9, 9 plus 9 is 18. Okay, let's do it like that, and later on you can write in the calculator also, okay. RS. Now I have to find out QT. Let's try to find out about the QT. So the coordinates of Q are negative 5 and 1, and the coordinates of T are negative 2 and negative 2. So let's try to find out. Use the distance formula. Again name them x1, y1 and x2, y2. So x1, y1 and x2, y2. So x1, x2 is negative 2 minus x1 is negative 5. So negative, negative, positive 5 plus y2 is minus 2 minus y1 is 1 whole square. So it will gives us 3 square, that is 9. This will give us negative 3 whole square. It will give us 9. So 9 plus 9, answer is 18. So we have proved that RS is congruent to QT. Now before going to the other part, let's find the slope of this one, so that from one side at least we can finalize one thing. Okay, so slope of RS. So the formula is y2 minus y1 over x2 minus x1. So here you have to look over here. So R and here is my S. So y2 is 0 minus y1 is 3. x2 is 2 minus x1 is minus 1. So plus 1. So it will give us minus 3 over 3. The answer is negative 1. You can use the calculator to get the answer. Now find the slope of QT. And where is QT? The QT, for the QT, the coordinates are here. This is Q and this is your T. So y2 minus 2 minus y1 is 1. x2 is minus 2 minus x1 is minus 5. So minus minus plus 5. And if you write here minus 3 over 3, the answer is negative 1. So you can say that RS is parallel to QT. So if we understood this part, then we can prove the same thing and do the same thing with the other line, that is R, Q and TS. Okay, now the same thing, but now we have to solve for QR and TS. This is what we have to find it out. We have to prove that the QR is congruent to TS. Similarly, QR is parallel to TS. To find the congruency, we have to use the distance formula, and to find out the parallel, we have to use our slope formula. So let's find out that the QR is congruent to TS. So what are the coordinates of the Q? The Q are minus 5 and 1 and R negative 1 and 3. Name them as x1, y1 and x2, y2. Use the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so using this formula, let's find out the length of QR. So x2 is negative 1, x1 is negative 5. So plus 5 plus y2 is 3 minus 1 whole square. So 5, 16, 16 plus 4, 20, square root of 20. Now we will find out about our second line, that is TS. So the coordinate of T are -2 and -2, and the coordinate of S are 2 and 0. So let's try to find out the TS using the same formula. Name it as x1, y1, x2, y2, and y2 minus y1. 0 minus -1, so it is +2 whole square. X2 is 2 minus x1 is -2, so it will gives us +2. So it will be 4, 16 and 4. So we have again got the 20. So what have we proved? That yes, QR is congruent to TS. Now second thing, we have to find out if QR is parallel to TS. So find the slope, and the slope formula is y2 minus y1 over x2 minus x1. So now your eyes should be on these coordinates, here and here. So y2. So y2 is 3 minus y1 is 1. X2 is -1 minus x1 is -5, negative, negative, +5. So 3 minus 1 is 2 over 4, which will gives me 1 over 2. Now next find out the slope of TS. And to find out the slope of TS, our eyes must be here at this side of the board. Okay, again let's try to put it in the formula. So our y2 is 0, y1 is -2, negative, negative, +2, x2 is 2 minus x1 is -2, negative, negative, +2. So 2 over 4 gives me half. So we can see that these slopes are equal, which means the lines are parallel. So most important thing is that you should know, to find out the congruency, you have to use the distance formula. To find out if the lines are parallel, you have to use the slope formula. Now let's see, find the values of the variables that make the quadrilateral a parallelogram. So now here the angles. You know that in a parallelogram it's important that the two opposite angles are equal to each other. So this is the converse of the angles of the parallelogram theorem. So I can say that these two angles are equal. So I can say that y is equals to 60 degree. Now second thing is these two angles. They are equal and they are opposite to each other. So I can say that 2x equals to 120 degree. Solve for x by dividing both sides by the 2. 2 cancel. 120 divided by 2 is 60 degree. So, but it is 60 degree x. I have to put it in this value. So 2x equals to 2 times 60, which gives me 120 degrees. So I can see that the opposite angles are equal to each other. Next, they are saying that I have to find out the opposite variables. Now here they are the diagonals. So remember that if you are talking about the diagonal of the parallelogram, so this part is equal to this part, which means 3y minus 2 is equals to 19. Similarly, the other here and here, these two parts are equal to each other, which means x plus 5 equals to 12. Now find the unknown variables, bring the -2 on the other side, it will gives you +2. So you will get 3 equals to 19 plus 2 is 21. Divide both sides by the 3, 3 and 3 cancel, y equals to 7. Okay, so solve for x now. Bring the 5 on the other side, you will get -5. X equals to 12 minus 5 is 7. Now, if you want to check your working, let's make it 3y minus 12 minus 2. So 3 in place of y write down the 7 minus 2. If you write in the calculator, 21 minus 2 gives me 19. So similarly, let's check the other part, that is x plus 5. Replace x by the 7, which is here the value. So 7 plus 5 equals to 12. So you can see that the both sides of a parallelogram, the diagonals, the half of the diagonals is equal to each other. Find the values of the variables. So you can see that the variables are lying on the line. So you can say that this x plus 5 equals to 2x minus 12 by using the converse of the diagonals theorem, 2x minus 12. Now bring the 2x there or x there makes same thing. I am bringing the 2x here, so minus 2x I will get. I bring the plus 5 here, I will get the negative 5. So here there is no number, which means 1 is here. So 1 minus 2, negative 1x. Minus 12 minus 5, I will get negative 17. Divide both sides by the negative 1. So the value of x is 17. Next, I can see that if this is O, so OB is congruent to OD. So I can say 2y minus 24 equals to y minus 2. Bring the y here. So plus y goes here, becomes negative y. Similarly, negative 24, bring it on the other side, you will get plus 24. Now there is no sign before the 2, it means it's a plus. And there is no number before the 1, it means it is 1. So plus 2 minus y minus 1, it gives me 1y, or only write the y, equals to minus 2 plus 24 gives me 22. Next question, find the unknown variables. So now look here, I cannot add any grade 7. If you take a ride of grade 7, m plus n if it's written, I cannot add them. So I can say that 7m plus 4 is equals to 11n plus 5, but to find the plus 15, but to find unknown variables, I cannot write that 7m plus 4 and 11n plus 15 like this mathematically and solve it. No, it is the wrong way. So what will be the correct way to find out the unknown variable in this case? So in this case, here is the m and here is the m. So I know opposite angles are equal, but besides these angles, they are equal to 180 degree. So I can say angle A plus angle D, if I solve them, they sum up to 180 degrees. So I can write 7m plus 4 plus 9m equals to 180 degrees. So 9 plus 7 gives me 16m. Bring the 4 on the other side, plus 4 goes on the other side gives you negative 4. So my answer is 176. Now divide both sides by 16. Divide both sides by 16. So here, divide by 16 and divide by 16. So m equals to 11. Now similarly, angle B plus angle C sum up to 180 degrees. So I will write 17n minus 3 plus 11n plus 15 equals to 180 degrees. 17 plus 11 gives me 28. Now Minus 3 plus 15 gives me 12 equals to 180. Bring the 12 here. It gives you negative 12. So 28m equals to 180 minus 12 gives you 168. And now divide both sides by the 28. Divide both sides by the 28. You will get m equals to 6. So this is how we find out the answer.